Hello and welcome. Today we're exploring a really fascinating piece of automotive history, a Porsche that's, well, a bit different. It's German engineering meeting Italian coach building flair out of sheer necessity.
That's right. We're talking about the Porsche 356B 1600 GS Carrera GTL Abarth. Quite a mouthful, isn't it?
Mm.
Built only between 1960 and 61.
A very short run, yeah. And this is the kind of story we love getting into. You can find this discussion and others like it over on our YouTube channel, Vintage Noise.
Definitely check that out. But yeah, this car, it's got the Porsche badge, sure, but its essence, its actual skin,
Right.
comes straight from Turin, Italy.
And not because Porsche just felt like it, right?
Yeah,
This
yeah.
was born from regulations.
Exactly, as a direct response to racing rules,
Mhm.
a purpose-built tool. And it raises a really interesting question. Why did Porsche, the icons of German precision, suddenly need help from Italian specialists for the body of their famous 356?
Okay, let's dig into that. The sources all point towards new FIA regulations being the main driver here. What exactly was changing? What did they need?
Well, the FIA brought in new rules. And the big one for Porsche was weight. They needed a much lighter car than their standard production 356 could ever be.
Even with the powerful Carrera engine.
Yeah, they had that amazing four-cam Carrera engine, which was, frankly, ahead of its time. But the standard steel bodies, the ones built by Reuter, they just couldn't shed enough pounds to meet the new minimum weight for the GT class.
So a serious diet was needed, and quickly.
Pretty much overnight, yeah. They needed to lose significant weight to stay competitive in that class.
And I guess building a whole new aluminum body facility in Germany wasn't really practical on short notice.
Not at all. So they looked south to Italy. Italy was, back then, the absolute hub for beautiful, lightweight aluminum coachwork, masters of the craft.
Makes sense. And they looked at a few options.
They considered several Italian companies, but eventually decided to partner with Abarth. And that decision immediately brings Franco Scaglione into the story. He was tasked with the initial design.
And his job wasn't just make it look good, was it? It was pure function driving the form here.
Absolutely. The main goals were all performance-based. He needed to reduce the frontal area, make it cut through the air better, and lower the overall height.
Less drag, basically.
Exactly. Smaller, slipperier. Every single curve was thought about in terms of aerodynamics, even down to details like that adjustable scoop you see on the rear deck lid.
Ah, okay. So that scoop wasn't just for looks either.
No, pure racing tech.
Yeah.
It was there to help balance airflow for cooling the engine versus aerodynamic drag. You could tweak it.
And the key to all this, the weight saving, came down to the material choice. All aluminum for the Abarth body.
That was the magic bullet for the weight problem. Compared to the standard steel 356, the aluminum made a massive difference.
How much smaller and lighter are we talking?
Significantly smaller in, well, every dimension compared to the standard Reuter body, and the weight figures are pretty staggering for the time. The finished car tipped the scales at just 1,762 pounds.
Wow. And the FIA minimum was?
1,780 pounds. So they absolutely nailed it. Came in just under the limit. Perfect.
Just think about that, 1,762 pounds. That's incredibly light, even today for a race car. Lighter than many modern city cars. They basically stripped a classic Porsche down and gave it this super lightweight Italian suit.
And like we said, it wasn't just about the weight. The aerodynamics were crucial too. That reshaping work Scaglione did really cleaned up the airflow.
Do we know how much difference it made, like the drag coefficient?
We do. The standard 356 had a drag coefficient, a seed of about 0.398. The Abarth version dropped that down to 0.365.
Okay, 0.398 down to 0.365. That might not sound like a huge number to everyone listening.
But trust me, at high speed, say, on the Mulsanne Straight at Le Mans, hitting 140 miles per hour or more, that reduction is enormous. It means the engine doesn't have to work as hard against the air.
Which translates directly to higher top speed, better acceleration at speed, even better fuel efficiency in those long endurance races.
Exactly right. It turned the 356 from a quick and nimble sports car into a properly focused aerodynamic racing weapon, a real scalpel for the track.
So the design looked great on paper, lightweight, slippery. How did the first actual cars turn out? The prototypes arrived from Turin in February 1960. Sources say they were maybe a bit rough around the edges.
Yeah, somewhat rough, I think is the term used. But that's often the way with initial race prototypes, isn't it? Especially when you're combining two different manufacturing philosophies, German precision meeting Italian handcraftsmanship.
True. But the roughness didn't seem to slow them down much.
Not at all. The proof was immediate. They were quick right out of the box, quick enough to win the Targa Florio basically straight away. which, is maybe the toughest road race imaginable, a real car breaker.
An instant win at the Targa Florio. That's a heck of a debut. Was that a factory effort or?
Well, Polstrail actually bought the second prototype built, and he was the one who took that first Targa class win. And he liked the car so much, he came back and did it again the following year.
Wow. Okay, so the potential was clearly there, even if the finish wasn't perfect yet. Did that early success mean Porsche just pushed them into production, or were there immediate fixes needed?
Oh, there were definitely things to sort out. Racing always reveals weaknesses. They found a pretty major issue with engine cooling almost immediately.
Ah, because of the tighter lower bodywork, maybe?
Exactly. The sleek aluminum body, being lower and more compact, didn't allow as much air through as the standard car. So before they really started building the main batch of cars, they had to modify the rear engine cover.
How so?
They added more ventilation. The sources describe it as an excess of louvers, basically lots of extra slots cut into the engine lid.
And that was crucial for keeping that complex four-cam engine happy, right? The Schubladen motor.
That's the one. The drawer motor nickname comes from its complexity. It was air-cooled, remember? So getting enough cool air in and hot air out was absolutely critical. If hot air got sucked back into the cooling fan, you'd lose power and risk overheating very quickly.
So adding those louvers was a necessary evil for reliability. Classic race car development, fix it as you find it.
It really is. You only truly find out what works under race conditions. So once they addressed the cooling, Porsche felt confident enough to commit to a run of 20 cars.
20 GTLs. And Carlo Abarth himself was managing the production over in Italy.
Yes, Abarth oversaw the project. But he didn't build the bodies in-house. He leveraged Turin's amazing network of small, specialized workshops, the famous cottage industry there.
So who actually hammered out the aluminum?
He outsourced the body construction to a coach builder named Rocco Motto. So you see, this wasn't like a Porsche factory assembly line. Each body was essentially hand-built by Motto's craftsmen.
Hand-built. That sounds expensive. And it was, wasn't it?
Oh, yeah. Very expensive for the time. The final price tag was around 25,000 Deutsche Marks. That translates to about 6,500 US dollars back then.
Which was how much compared to a standard 356?
Almost double the price of a standard high-spec 356 Super 90. So you weren't just buying a slightly tuned Porsche. This was a dedicated, purpose-built, and largely handcrafted racing machine.
And that hand-built nature using guys like Rocco Motto, did that lead to differences between the cars?
It absolutely did. That's a key point the sources mention. Because they were hand-formed aluminum, there were subtle variations from car to car. Things like the exact body contours, the fitment of taillights, maybe even the shape of the side windows could differ slightly.
Slight differences. You have to wonder, for a factory race team chasing every 10th of a second, wasn't that kind of variability a bit of a headache? You want consistency, right?
That's a really sharp observation. For private racers, maybe those small differences weren't a huge deal. But for the Porsche factory team, yes, it likely presented challenges.
How so?
Well, it meant each car was almost an individual. They'd have to learn the specific quirks of chassis 1013 versus chassis 1018, for example. Tiny differences in weight balance or aerodynamics could affect handling and setup.
So the mechanics and drivers really had their work cut out for them, dialing each specific car in.
Definitely. It's actually a testament to their skill that they manage that variability and still achieve such dominant results. They made it work.
Okay, so the first production cars, variations and all, they make their debut at the Nürburgring 1,000 kilometers. Which brings us nicely to what was under that louvered engine cover, the heart of the beast.
Right, the engine.
Yeah.
While the early prototypes used existing Carrera engines, in 1961, Porsche introduced an even stronger version specifically for this kind of demanding work, the Type 6923A.
The Type 6923A. Okay, now we're getting into the really interesting technical stuff. What made this version special? They weren't just chasing peak horsepower, were they?
No, not just peak power. It was about durability and sustained performance at high revs. Think about endurance races like Le Mans or Sebring. The engine has to run near its limit for hours and hours.
So what specific changes did they make inside the 6923A to let it handle that kind of abuse?
They beefed up the bottom end, primarily. Wire main bearings were introduced. That helps spread the load and allows the crankshaft to spin reliably at higher RPMs for longer periods.
Stronger foundation. What about the top end? Cams, breathing.
They changed that too. More aggressive intake camshaft profiles were used to get more air and fuel mixture into the cylinders, improving volumetric efficiency, especially at high revs.
And the source mentions something quite unusual, small flywheels added to the ends of the camshafts. That sounds really specific.
It does, doesn't it? It's quite a technical detail. Those little flywheels were likely there to help dampen vibrations and stabilize the long, complex camshafts and their intricate gear drives at very high speeds.
Ah, so like mini harmonic dampers for the cams, keeping everything smooth and preventing gear train issues at 7,000 plus RPM.
Exactly. In a four-cam engine, keeping the valve timing precise and the gear train stable under load is absolutely critical. It's the difference between winning and, well, a very expensive mechanical failure.
Makes sense. So a stronger bottom end, better breathing up top, stabilized valve train. What about feeding this hungrier engine, carburetors?
Right. Porsche had used Webers on Carreras before, but for this GTL setup with the 6923A, they actually went back to Solex carburetors, specifically the larger Solex 44 PIF4 model.
Bigger Solexes. And how much power did this optimized setup actually produce, especially with, say, the loud exhaust?
When fitted with the optional, essentially unmuffled, Sebring Sports exhaust system, this setup was good for a claimed 165 brake horsepower at a screaming 7,400 RPM.
165 horsepower from just 1.6 liters. Well, 1582 cc to be exact. In a car weighing under 1,800 pounds, that's a serious power-to-weight ratio for 1961.
Really was. That combination delivered serious performance.
What kind of speeds are we talking? Top-end acceleration?
Top speed was up around 144 miles per hour. That's about 231, 232 kilometers per hour. Pretty quick. And while it was really built for endurance and top speed, it wasn't slow off the line either. 0 to 60 miles per hour took roughly 8.9 seconds.
Impressive all around. These things must have been absolute rockets in their class.
No question. They were dominant.
Okay, so we've got the lightweight body, the slippery shape, the potent and durable engine. Let's talk results. We know about the early Targa wins, but how did the GTL Abarth perform consistently over its short life?
Its legacy was really cemented over the next couple of seasons, from 60 through 62, even into 63. That 1960 Le Mans 24 hours was a big one.
Right, you mentioned that earlier, just one car engine.
Just one GTL, yeah.
Okay.
But it showed its speed on the Mulsanne Straight, hitting around 138 mile per hour thanks to that aero and engine power. And the drivers, Herbert Linge and Paul Ernst Walter, brought it home 10th overall.
10th overall for a 1.6-liter car at Le Mans is fantastic.
And crucially, first in its class. A dominant class victory. That really announced its arrival on the world stage.
Put everyone on notice. This wasn't just some Italian special. It was a reliable winner.
And the wins kept coming. Paul Strahl, as we mentioned, won his class of the Targa again in 61. But the factory effort really ramped up too. They started campaigning chassis 1013 quite heavily.
Car 1013, that one saw a lot of action.
It did. Its big moment came at the 1962 Sebring 12 Hours, where it took the 1600cc class win. A major endurance victory in America.
So Porsche was clearly gaining confidence and committing more factory resources.
Absolutely. Later in 1962, they brought out another GTL, chassis 1018, to race alongside 1013, and that pair became almost unbeatable in their class.
A two-car factory team, where did they win together?
They scored class victories at the Nürburgring, the 1,000 kilometers that year, and then significantly another class win at the 24 Hours of Le Mans in 62.
Le Mans again.
Yeah, and that successful duo, 1013 and 1018, carried on into 1963, taking class wins at the Daytona Continental Race and then another class win at the Sebring 12 Hours.
Wow. So despite only being produced in 60 and 61, these 20 or so cars just dominated their class for 3 solid seasons. It really proves that focused design collaboration worked wonders when the rules demanded it.
It really does. If you step back and look at the GTL Abarth story, it's a perfect little snapshot of how racing pushes innovation, isn't it? You have these regulations, these constraints, and then you see engineers and designers get incredibly creative to find an advantage.
A boutique race car, really?
Totally. Highly specialized, born from this unique German-Italian collaboration, designed purely for lightweight speed and endurance. And boy, did it succeed at that mission. Massive success.
Right. It really was a hand-built racing special. And thinking about that high price, the fact it came from Turin's cottage industry, it makes you wonder, we talked about those small differences between cars. How much do you think that variability, that hand-built character in a world aiming for precision, actually impacted the drivers and teams fighting for every last tenth on the track? Something to think about.